Okay, and good morning. And that's some new music this morning. That's John Mellencamp. And what was that cut on that, Will?
That was a Ride Back Home.
Ride Back Home. That's what we'll do at the end of this week. We have more word problems. I've had some positive remarks that it's getting easier. I've had some remarks that I think the phrase Michael used, chipping away, like it's granite and you're going to keep plugging away on it. And we have a large number of students who appear to have plugged away out of the room this morning. Give you an idea of what we're up against next week, because we are going to have a test. And so the question that was asked, and it's one that I need to address, and that is how many problems of the type you're doing right now. Okay, so if we think of where we've been, and this is the idea that we have to plan ahead a little bit. We are in 4.4 and 4.5 have given us some difficulty. Now you're certainly going to be given a problem of the type from 4.4. And it seems that we've had 3 different types of word problems in 4.5, and I would see giving 2 out of the 3 in the test. So 2 problems in the test out of 3. Now that, thinking in terms of maybe a 20-question test, that would mean you can miss both those and just hang in there and still get an A. So that's the intent. Now, in those problems, identify your variable. That gets you some credit. If you have a diagram, draw the diagram. That gets you some credit. If you get an equation, that gets you credit, and you might not be able to solve the equation, but you have 3 out of 5 at that point. If you look at 4.4, at least one of those, so there's 3 problems from that material. Now, I'd like to talk about chapter 5, for just a moment before I answer questions. Chapter 5. The first section I've asked you to do is just a review of what we've done before. Now, I'd like to look a little bit of what's happening in 5.2 and 5.3, because as it stands, that is material that is involved with what we are doing right now. This is sort of a strange kind of combo, if you will, because in many respects, what you're seeing here with fractions and mixed numbers as we go to the document cam, that's 5.1, and that's straightforward. Now, simplifying fractions, meaning reducing them, you've done that before as you have multiplied fractions, divided fractions, and found least common multiples. In a way, everything in this 5th chapter involves about 80% old material. Now, I want to give you an idea, because what I have to decide is just how far I want to push this in terms of prior to the test. So I want to try to illustrate the kinds of things that you're going to see in 5.2. So, for example, these kinds of problems. And this is sort of mundane for where you've been, reducing a fraction, and you're not asked to do it necessarily with primes, just reduce it. That's on page 313. It's on the document cam, or I should say was. There we are for a moment, Will. That's old hat. You should be able to do those. Take a look at them. Everyone, please, take a look at the document cam and answer the question. Can you do those, just as you're looking at them? I hope the answer is yes. Let's come off there for a moment, Will. Going further, we come down to something like this. The only difference, these are improper fractions. Again, shouldn't be a problem. We throw a few negative signs in with it. Should be no problem. This is where we get into trouble, just a little bit. And this is the last third of the problems where we have variables. Okay, and I hope you look at that and say, well, the numbers are okay, the k and the k reduce, and you have an h squared left in the denominator. I would think that these shouldn't be giving you much difficulty, and it's the last. Let's see, we have 12 problems there, and that whole set are worth looking at. Okay, coming off there from Will. Yes?
Why was there like a dash in between the fractions?
A dash?
It looked like it was almost like a negative fraction.
Okay, on number 46, as we come back, that's a minus sign in front, so it's a negative of the fraction. So it's not a numerator that's negative or a denominator that's negative. The whole fraction is the negative. Okay, coming off there. If we look at 5(3), and what I have set up for next week is 5(2), 5(3). And as I'm looking at these, so much of what I'm seeing in 5(2) and 5(3) is repetitious of what we've done and where you should be. So let's look at what's involved here with multiplication. So again, back to the document camp. The only thing here in number 18 is you have to do some cross-canceling, correct? Again, my hope is you look at that and you think, okay, I can do that. So I slide over. The only difference here? The signs. So in number 27, since you have a negative multiplied by a negative number, you will get a positive. Shouldn't be a problem. Agreed? So we drop down to make things more difficult. Now the only difference here is that you're supposed to do an estimate, and the estimate, 5, 6 is close to 1, so you should get 1 times 28. That doesn't make a lot of sense to me, but in terms of trying to make an estimate. But note, you put a 28 over a 1 and then multiply. So then you're going to have 2 going into the 28, 2 going into the 6. So you have 5 times 14 over 3, and that's where you get the mixed number. Again, not worth much. Coming up to 39, these problems. We've done them before, except for the estimate part. But if I look at that, let's see if I can get that. There we go. What do? What's the step that has to happen here to multiply mixed numbers? Improper fractions, common fractions, improper fractions. So you change each. Don't need a common denominator in these because we're multiplying. So it's just change them to improper fractions and cross-cancel. So that's still not much of a difficulty. It isn't until we get down into the 40s that you get problems like this, like 53. There we go, Will. And again, it's the variables that you have to work with along with the numbers. So there is a set, in this case, of about 23 problems. So my goal here in looking at these as 5(2) and 5(3), so you understand where I'm coming from. I think on Monday I'd like to cover 5(2) and 5(3) with the idea of seeing how we can do. Then Tuesday we come back and we talk about them and make sure we're okay there. And then Wednesday we have the exam. Thursday I'm going to have what we would consider the tutorial at that point. And this is necessary because of the schedule that Palomar has. There were 2 periods of time where they were having conflict because of a Board of Governors meeting. And so if I ran the tutorial on a Thursday instead of a Friday, then we don't have a problem with their broadcast. So that means on Friday will be a full regular day of presentation. It won't be the usual tutorial that we have on a Friday. So that'll be the full presentation on Friday next week, not a tutorial. There's a balance here, and I'm hoping I'm not pushing too hard on these fractions. What's very clear, this weekend, you dig out Math 10, and you look at lessons 7 through 13, and you review from Math 10 how you add, subtract, multiply, and divide the fractions from 7 through 13 in Math 10. If you can do all that, then we should be able to just focus on the variables, and I think you're going to find that after the word problems we've been struggling through these last few days, that that's a breath of fresh air. So on the test, I will have problems from 5(2) and 5(3). I don't look to test you again on your ability to do arithmetic with fractions. It'll be with the variables. So you're looking at probably a minimum of 3 or 4 problems from Chapter 5 in the test, and from 4.4 and 4.5, 3 problems minimally. Then the question is, what else on the test? So that's where I want to come back. We have 4.1, 4.2, and 4.3 that need to be covered in the test. So let's look at what we had there. And in terms of problems from Chapter 4, now 4.2 was addition and subtraction where you simplify an equation, right? And you just get x by itself. You never ended up with anything else. Number 3 was you simplify and you get something like 4x. And so you have to divide by 4. So as we look at those, I would see 2 problems from 4.2, at least 2 problems from 4.3. So if I just leave that there and leave that up for a moment, Will, as I try to indicate what we're looking at. So you know how to prepare. This weekend is going to be an important time to prepare. So if we look at these sections as we go to the board, we're talking 2 problems from here. I said 2 out of the 3, so that you aren't getting too much weight there. In terms of 4.4, should probably go with 2 from there, because those are the translation problems. They aren't as hard as the word problems. Then 4.3 and 4.2, as we go back to the document cam, these were with equations. And remember when I gave you the quiz in these, I took hard ones? Yeah. I think I'm going to go 2 from each of these, but 1 will be easy and 1 is hard as we go back to the board. So you'll have an easier one and a harder one, an easier one and a harder one. So we're at 2, 4, 6, 8 right there. From 5.2 and 5.3, I'm looking at minimally 2 problems from each of those. Now, did we have 4.1 on the last test, where we had just solutions to equations and demonstrating? We had it on the quiz, where I said show that a number was a solution, but it wasn't on the first test. So from here in 4.1, if we sort of follow this idea, maybe 2 problems from each section on the test, which is not a bad idea to take as a way of doing this, that would give us 1, 2, 3, 4, 5, 6, 7. I'm up to 14 problems. Now, in Chapter 3, trying to remember on the first test, and I was trying to go back to that in terms of how far. When we finished up in Chapter 3, we did Chapters 1, 2, and how far did we go to in Chapter 3 for that first exam? Because we worked with whole numbers, exponents, then we went into integers, we did order of operations.
We did
all of 1 and 2. Did we do Chapter 3 also for the test? Okay, let me take a look at something. I'm going to come back center on this for a moment. And if I go back, let's see what I have on the website, because I brought that up so we could look. And yes, as we look at what we have here, I'll bring this up a little bit tighter, and let me come to here. As we look at this, Will, as we come into this, and I'll just scroll down, this is the weekly schedule, and when we had our test, we had our exam 2, and it went up through, no, exam 1, sorry, I went too far. Exam 1. There's week 1, week 2, week 3, week 4, and in week 4, we went Chapter 2. So as I come out of that, as I look at what's involved there in activities, we went up through 3.2 before the exam, which was Introduction to Polynomials. So as I come out of that a little bit and zoom in at the bottom, okay, this is what we were doing in that week prior to the exam. We did 3.1, 3.2, and then we had the test. So I believe in terms of what I would have included in that, we went up through 3.2 before the test. So on Introduction to Polynomials, that's where you had to identify a binomial, trinomial, and you had to, let's see, in 3.2, let me go to that just so we can get our bearings as to what we need to be reviewing. 167 was on 3-2, and this is where you simply identified what you had and you wrote it in reversed order, descending order. So that means for the test, we should be looking at 3-3, 3-4, 3-5, 3-6, and 3-7. So let me bring those in. So 3-1, 2, 3, 4, 5, 6, and 7. And we had done these two in the test. So if I were to do something like this, taking that same idea, 1, 2, 3, 4, 5, that would put me at 10 more problems, which would put me at 24. And what now? 5-1? No, that's just a review of arithmetic with fractions, and I'm not going there. There was nothing in 5-1 that I could see was going to involve you with any algebra as such. I looked at the problems there, and I didn't see anything that would do that. That was just, well, let me double check. Better be careful. But I want to make sure 5-1, and as I'm looking at the problems, there's nothing in there that we didn't do in 10. So at this point, what I might be inclined to do in some of these sections is reduce it down to one problem in some of these, or go 25. So it's either be 20 or 25 problems, depending on how I cover it. But we're going then from 3-3 to 5-3. That's my goal. Now, if it turns out, and this is where you need to be flexible also, if on Monday I find that 5-2 and 5-3 is not going as well as I'd like, then I will just simply make the test on chapters 3 and 4, and that would bring me down to 20 problems. Okay? So we're clear what you need to be responsible for. So it's starting with 3-3 and going up through chapter 4, may include 5-2 and 5-3 if it goes smoothly. If not, just chapters 3 and 4. Okay. I've managed to avoid long enough questions on homework problems. Okay. So Sandra, you said you had some that you wanted me to look at, or?
Yeah, I have one.
Okay.
And it's off the computer.
Okay, off the computer. Do you want to read it to me?
Yeah, I just got the basic information.
Okay, basic information. This is
It's regarding stocks.
stocks, okay?
This lady owns stocks, and her stock A is 4 times
The amount she has in stock A is 4 times the amount she has in...
stock B.
Okay, so we have stocks. For those of you who are thinking of stocks as something other than economics, okay, what we're talking about here is the Wall Street kind of thing. You own shares in a company, and those are called stocks, and so you have A and B. And so
And then she has 8.
A is 4 times B. Is that the way you're reading it? 4 times as many as B?
Well, it doesn't give, well, yeah, but it doesn't give me, I have to do it all on my own.
No, I know. It's just saying that you have 4 times as many in
Right.
one than the other.
Right.
So what I would say is let X equal number of stock A. Now my point is X does not equal the stocks. X is to represent a number. So it's the number of stocks that you have from that company, number of shares. And then B is 4X equals number of, helps if I manage to spell that correctly, of stock B. So that's my information in terms of the two pieces of, or two numbers. Now, is there something else that's stated?
There's 18 shares in stock A and 15 shares in stock B. Total of
Okay, hold it. Then something that's been stated doesn't make sense. Because if you have 18 shares of one and so many shares of the other, then what I have written there for X and 4X is not the same. Go back and give me the prelude again. How did it start?
Okay, so-and-so has 2 stocks. the first stock A is 4 times more than stock B.
Meaning the price of the stock, not the amount?
It didn't say.
Yeah, the price.
The price. So let X be the price of stock A, and B is the price of stock B. That's starting to make more sense to me. Now I have some more information.
Yeah, and there's 18 shares in stock A.
So 18 shares. Now, by the way, what I'm doing here is sort of summarizing the kind of information that I get out of a problem. So I'm just taking notes. And then you have 14 shares of the other, is that what it says?
No, 15.
15 shares of stock B.
And then the total amount between both stocks is $435.
So I have invested $435. Now I can make a table in a problem like this,
That's what they did.
but if you think about it without the table just for a moment. If I have X shares, the price of the shares being, this is the amount per share. So this is the amount or the price per share, I guess is the way I want to say that. So if I'm going to do this with a better statement, still trying to understand the problem, X is the price of each share of stock A. If that's the case, and I have X shares, 18 shares, and this is the price per share, then my value of that stock is going to be the product of the number I have times the price per share. So I'm saying 18X is the value of those 18 shares of stock, which each share valued at X dollars. Michael.
I think the price of each share should be stock B.
Doesn't really matter too much as long as when I'm done, I have the ratio correct. Now, one stock, A, is valued 4 times as much as the other. Is that the correct? So the first stock is 4 times the second in value. Then what Michael's saying is valid. This evidently is to be the price of the second stock, and 4X is the price then of the first stock. I didn't hear that well when I listened. So if that's the case, then this is going to be multiplied by 4X because it is the more expensive share. Now, the value of your other 15 shares is that X dollars per share, and that is to equal, what is it, $435 invested? So this person's not investing a whole lot of money. So what I have is amount invested in A, amount invested in B. And so what we're talking about is how to set this up with or without a table. And this is equal to your total amount invested. Now, as a table, I can set up much of what we're doing here. And I can say I have shares. So I can say number of shares, price per share, and total value of the stock. If I do that, the question is, Robert, if you do the honor, there's a straight edge right behind you. I'd appreciate that. The guy says, okay. Thank you. And the question I've always asked, and I don't have a quick answer for this, textbooks very often do tables. And I don't know if they provide the kind of benefit that we expect of them from the standpoint, if you know how to do the table, you don't need the table. Price per share. Number of shares. A, B. One more. Again, I'm just thinking of doing the table to help me organize. And the question is, do you then need the table? Because now I want what in this last column? A value of your stocks. So if this is going to be for price per share here, and we said that's going to be 4x, whereas this is x, and you have number of shares, so here we have 18 of them, here we have 15 of them, and then you say, well, the value of that is then 4x times 18, and this is x times 15, and then down here you say something like total value, and that's to be $435, then you add these two and get this. That, in essence, is what we did. So the question, does the table help you organize or not? You like the table.
But it has the value and the price switch.
Doesn't matter.
Oh, it doesn't? It's not?
If you have this reversed from here?
No, the value was the price.
Okay, so they did the 4x here times 18. That would be unusual in my mind for a table. Usually at the end, you think of multiplying these out and you have your equal sign here. Whether you switch those or not is independent. I mean, doesn't really relate a whole lot. My attitude, again, is mixed on this. I'm very conflicted because I find that if I read through the problem and structure and try to interpret what's there, it's exactly what I have to do when I create the table, so I really don't need the table. But a lot of people like the structure of this and feel more comfortable with it, and so I don't object to it. If I give you a problem and I don't give you a table, can you construct the table? I mean, what's done at this level, whether it's an algebra course beginning, a pre-algebra, or an intermediate algebra, you'll find early problems with a table trying to structure for you the thinking you should do. Then, very shortly, we give you problems and no tables, and then the question, do you create the table or do you think your way through the problem? What I'd like to get to as I come back here, Will, just to that equation to the left of this table, so that's right over here. As I go back to there, what I wrote here, amount invested, your total amount invested, is not any different than what we are going to say in two different kinds of problems I related to yesterday. And this is my effort to sort of push you a little bit further, and hopefully not over the edge. A similar problem. Back now, Will, to the other where I'm going to talk about two cars going in distances, opposite directions. So you happen to be at a vacations place and you're now going home and you happen to go in different directions. So you vacation somewhere, you met somebody, and so you talk about taking off. So this person's going to place A, this is going to place B. A and B again. And here I say, okay, one person's going to go very slowly. Let's say this person's going X. They are very conservative. They have trouble with their car. It's barely running. So they're going to do maybe 20 miles an hour is the best they can hope to do. And here's a freeway over here and you're doing 4X. Same process, right? Except that we have the numbers slightly different. Now, in this case, I'm going to have that this person only has to go 15 hours where they're going, and this person has to go 18 hours where they are going, and the total distance is 435. It's the same problem. Because your total distance is rate multiplied by time. That's back to our how much problems that we did in the orange book. So this is 18 times 4x. That's your distance here instead of what? instead of the amount of money invested, it's just the distance you went. The other distance was 15x because you're going 15 hours at x miles per hour. And that must equal 435. Now, we get the same result out of this. The numbers are going to seem strange because I've tried to use the same values, and I have a hunch we're going to find a pretty slow speed. Maybe this person's riding a bike. This is 72x. This is 15x. That's 435. So you ended up with what? 87x? 435. And so indeed, this person is riding a bike for 15 hours. That's how they got there. Okay, so they rode a bike at 5 miles an hour, and this person at 4x has a very slow car. Or they're a very fast bike rider. Now that's maybe not so bad. If we think of the Amgen tour, they're going to ride their bikes back home just to relax. They've been cruising along like heck, and this person's going to do 5 miles an hour. This person's doing 20 miles an hour. 20 miles an hour is noticeably different than 5 miles an hour. So these are bicyclists. Now I got the same problem.
I got all the way up to that part, so I got 5x equals 5, right? But I couldn't figure out how they got that 20.
4 times 5. If you have x and the other is 4x and x is 5, substitute in. 4 times 5. You got the hard part, and then you tripped up on that last little... Yes?
Yeah, the problem at first one was mixed with the
Okay,
X, like
sliding
X.
over here, or back to the camera. Here, what? Okay, it's where she had the x and the reversed. Okay, and that would change. It will mess it up. What I would like to have you understand, that the process, whether this was a problem about distances or stocks, the setup's very similar. So if I do it in terms of a table instead of the price per share, I'm sorry, Will, I caught you in between. The price per share, I would say what? Speed of the bike. Here is number of hours riding. This is miles you rode. So if you were going X miles per hour for 15 hours, this becomes the distance. So this becomes a rate, this becomes the hours, and this becomes the distance. Just like when you go down the freeway at 70 miles an hour on I-5 legally, 70 miles an hour for 4 hours, you multiply 4 times 70, and you say 280. So here we're saying, in the problem I just did here, 2 distances add up to 435. Here, in the problem where we were talking about amount of value, the amount invested total is 435. The structure is the same. If the table helps with that, so be it. You choose which way you want to go. I, as a personal preference, like to set up in my mind more of, and I'm going to go now over there, Will, I like to set up a kind of verbal equation. Amount invested in A, amount invested in B, add them together is the total amount invested. The distance I ride at A plus the distance I ride at B must be the total distance of 435. So I write a verbal kind of statement and then work backwards from there. Again, without making this go on forever, you have to start seeing that common structure. Not that every problem is different in totality. Now, Sarah and I talk about this quite a bit because in the algebra class, you'll walk in and you'll say, okay, are there questions on word problems? And you'll go through 3 word problems, and then another person has the same kind of word problem, it's just numbers are slightly different, and see nothing in common. You've got to see patterns. You have to see a common type of solution, that we are equating either amount invested or the distance ridden. That's the kind of thing that you're doing. One last comment. I talked about mixture problems. Okay? So if I have mixture problems, we end up with much the same kind of thing. Namely, instead of the price, it will be maybe the concentration. So this is a 5% solution. That's a 20% solution. And this is the number of liters I have. And then I'm told that at the end I have 435 actual ounces of salt. So I have a saline solution, X concentration here, 4X concentration here, 5% and 20%. These are the number of liters I have. If I multiply the liters times the concentration, that is the salt in the first plus the salt in the second, and it's supposed to be 435 grams of salt. Same problem. It's a mixture problem now. Okay, enough. Yes, Nancy. I could. Which problem is it you're wanting to do?
It's from 4.5.
Okay, 4.5. Is this one in the book or from the computer? Okay. At this point, I think I'm going to leave. Are you in camera 1 right now?
Yes.
Okay, leave this here. We'll just leave this on the screen. We'll take camera 2 to the side. I'll get closer to Nancy. We'll try to carry this through. Now, here's the danger for some of you while Will's doing that. And I don't know to whom I'm speaking. If you have been putting your time in, meaning a couple hours, then what we're talking about should be helping. If you haven't spent the couple of hours for the last couple of nights, each night, trying to do word problems, then nothing of what I'm doing is going to help you. You have had to basically spend the time. Otherwise, this isn't doing a thing for you. And I don't know to whom I'm speaking. But unless you put in the time, you are not going to get this. And putting the time doesn't mean you've got it. It just means you're making progress. And in a pre-algebra, I'm not expecting you to be able to do what we would do in a Math 70 class, because each of these problems you would see in a Math 70 class. The difference, we'd spend 1 day on, not 2 or 3. Okay? And we'd be into a different type, because I just covered distance and I talked about mixture. We'd be another set of problems, and instead of having the number you had for a couple days, we would have that many per night and move right on. So you have the luxury of putting some time in, but you've got to pay your dues. So if I take the soccer analogy, Ephraim tells me soccer's starting, and if you don't train and you don't spend time practicing and you go out and play in a match for an hour and a half, 2 45-minute halves, you're going to be sucking wind, and people are going to be kicking butt because you aren't playing at the level you should. And that's precisely what we are in here doing now. You're training so that when you have to do a test, you've got a chance of succeeding. Okay? So that's part of what we're talking about. Now, I'm going to go over and answer Nancy's question. I'm going to leave this on the screen, but just an admonishment to you. If you haven't put the time, a weekend's coming, you will, at this point, have to spend 50% more time than before. That means you owe me 6 hours this weekend just on section 4.5. So with that said, let me go over to the side. Hold on. This is back to Nancy's question. Okay, Nancy, let's try sharing the problem you're talking about. What is the problem going to be?
The perimeter of a basketball court.
Okay, so we have a perimeter of a basketball court because you're speaking softly and it has to be heard by everybody else. So we have a perimeter of a basketball court, and the basketball court is maybe a rectangle?
Yep.
I'm hoping. Traditional basketball court. Okay, so 2 squares involved. Okay, what else does it say? So I have a perimeter.
The court is 96 meters.
96 meters what? Long, short, wide?
It just says meters.
The perimeter of the court. Is that what I'm reading?
Yeah.
Okay, the perimeter of basketball court is equal to 96 meters. Okay, so we got that information. By the way, what would you now do that I don't see on Nancy's paper? And not seeing it in Nancy's paper would cost her, on a 5-point problem, 20% credit the minute I look at her result.
She draw the picture.
I don't see a picture, Nancy. No picture, you're going to dock 1 out of 5. So just remember, pictures. Okay? Now, if you argue you don't play basketball, then you ask somebody what a basketball court looks like. But you have to assume that it's rectangular. So we're going to have something like this, just a standard rectangle. But I have to see these pictures in geometry problems. Okay, so there's my court. Without the hoops, without everything else. Now what?
And the length is 6 meters.
The length of this is 6 meters. Okay.
Then twice the width.
Whoa. Read that again to me. The length is 6 meters more than twice the width?
Yes.
Ah, but you didn't say more than. So 6 meters more than twice the width, where I must evidently have to identify that x is the width of my court. So I'm now at x, and the length is 2x plus 6. Is that correct?
Yes.
Okay, now what?
And then it just asks us what are
The dimensions?
and the width.
Length and the width.
I found the width, but I had a hard time with the length.
Okay, but let's wait a minute. If this is the length, we're back to the same kind of question I think that Sandra was asking. If you can find x, and that's the width, if the length is 2x plus 6, what did you get for x?
12.
You have 12 for x? So you solved an equation, which we haven't looked at yet, but you're telling me that you get a 12 here. Is that correct? I'm just asking what you solved. You said x was 12. Is that correct?
No. X is...
Okay, let's set up the equation. Twice the width plus twice the length is going to be the perimeter, correct? So my perimeter is going to be 2 times the width plus 2 times the length. And where did that come from? A formula from Math 10 that you're supposed to have memorized. So now we substitute. The perimeter is 96. The width is x. So I have a 2x. And then the length is what? 2x plus 6. Is that correct? So I substitute. Now that's my equation. Diagram, equation, and variable. Nothing else. That's 3 out of 5. 96 is 2x plus 4x plus 12. Combine, 6x plus 12 is equal to 96. I subtract 12 from both sides and get 6x equals 84. Do we agree? I divide by 6 and get what? 14. So it appears that my width over here, and let me maybe rewrite this a little bit more clearly as we slide over, Will. The width is equal to x. Now I found that x is equal to 14. Now if that's the case, and this is your length, this is back to chapter section 4.1. Am I right there where we no, this is all the way back to the idea of substituting into maybe chapter 3.1. Otherwise, if I know this, that length is this, and x is 14, can't I substitute? If the length is 2x plus 6, and x is 14, I'm going to substitute the 14 for the x. So that's 28 plus 6, and I'm going to get that my length is 34 feet. So if I can get x, I can substitute, and this is back to if I have x, what's 4x? If x is the width and the length is twice that plus 6, substitute. So my dimensions are, and remember the question at the end, what are your dimensions? What's the width and the length? Well, you have to say that it is a court which is 14 meters wide and 34 meters long. Okay? Does that answer your question? Now again, my concern would be I don't see a diagram. I must see that. And I will take off points if I don't. Sandra.
Okay, you said we have to draw a basketball court, but since that doesn't look like a basketball court, we just take it off. It's just a rectangle. No, I'm serious.
You want to clean it up a little bit, shave it, paint the corners.
Should I put stands here on both sides? Yes. And a gym doors over here, and a hoop here.
And a Laker sign in the middle.
Oh, Laker sign in the middle. I'm being a smart ass. But in terms of what we're doing here, do you have to have all these embellishments to have a basketball court? The key was it's a rectangle. Now, out of curiosity, does this satisfy that condition that you have a square in each end? No. If the length is 34 meters, that's 17 meters here, so we have 17 by 14. So it's not exactly a square. Okay? But I still have a rectangle. Now, if coming back to the front board right side with camera 1, and I'll leave this here. So just adjust camera 1 over there in the right side, a little bit more to the right than that, where I have my bicyclists. You can do stuff like this. I've got them going against each other, but bicyclist riding. Something, but at least have some distances, an A and B or something like that. Draw pictures. Now, I'm going to come, at this point, we're just going to go back to that over there for a moment, and then that'll free up your camera 1. So go back to camera 2 where you were with that, if you would, Will. Now, that was a diagram there. And again, let me talk about solving things as we come back center. When you solve problems, you understand the right brain, left brain activity kind of thing we talk about? Left brain is analytic. The right brain is supposedly artistic, and so somebody in science is going to use their left brain. And if you're in music or art or literature, you're going to use your right brain. On these problems, when you draw pictures, you're sort of forcing yourself to go right-brained a little bit, left-brained when you're looking at the equations, but you're trying to bring two parts of your head together to solve problems. One of the things that helps, and I said this either yesterday or the day before, is to talk out loud about these problems. Try to do what we are doing in class. And what you don't realize sometimes is that as we talk about it, that is an auditory kind of thing that you're hearing as opposed to reading. So I've even reached the point, and there are problems, folks, where I don't care what level you are. You look at the problem and you don't have an idea in the world where to start sometimes or how to solve it. And so I will personally end up reading it out loud to myself, walking back and forth in front of a refrigerator, talking to myself, trying to explain the problem and see if I'm missing something that I don't get if I just read it. If you call up somebody and you talk to them, lifeline kind of thing, you're on a quiz show, I get one call. So I call somebody, I'm thinking of Slumdog Millionaire, where, again, you make that call. You call somebody, and it's not so much that they have the information, it's that you're what? You're explaining it. So whether it's Nancy explaining a problem to me, or Sandra explaining a problem to me, or Michael explaining something to me, or James, the key is you're talking about it. Isolate yourself and just read it. Don't talk out loud. Don't talk with each other, and you're going to have more problems than if you do the other. Don't isolate yourself in these. And again, the expectation that you're going to suddenly have this clarity and you just are going to see any word problem and know it immediately, not yet. But you've paid your dues and you're getting there. That's the key. Now, if you've got these and you're doing great, then work with other people who aren't doing so well and see if you can increase and double the number. So if each of you who do well talks with somebody else who then does well, and we go from 2 to 4 to 8, and you can change the world exponentially, it's called, doubling something each time. These problems I've left open for you through the weekend. Now, for tomorrow, I'm going to spend some time answering questions to some degree on word problems. But I'm going to then talk about 5-1. This gets back to 5-1, where the fractions. And I'm going to go into 5-2 and 5-3 just to set the table a little bit. So over the weekend, since you will have all your word problems done by that point, you can start doing some other things. Now, the reason for that, I'm going to use another phrase, walking away from the problem. If you're working in a problem and you aren't getting it, it pays to walk away sometimes. Now, Sarah and I tease each other about, you're working in a problem for a while and then you get up and you do something else. So maybe the back lawn needs trimming. So you go back and trim the back lawn for a while because you're doing something that what? Isn't involved with the problem. I go for bike rides because when I'm riding the bike, the mind sort of goes into freewheel. You aren't thinking, and suddenly ideas pop into my head that I hadn't even known I was thinking about. Give yourself that subconscious activity. Try walking away from some of the problems. And by having you do something with fractions tomorrow and working in some of that other material, I'm hoping that something comes in that kind of, I got it now. Now the question is to hold on to it. Because you may get it, and then like that elusive fish that does that little wiggle and then it's gone. That's the problem you face. How to make sure that you have it. Pictures, tables, you name it, there are 3 different types of problems. Now, anything else with the word problems? We've only heard from about 3 or 4 of you. Anybody else with the word problem that you want to talk about? James? Okay, a question.
Our exam next week, this is our midterm.
Okay, exams versus midterms. In Math 10, we had a midterm that was a rather profound test compared to the other review tests we took. Every one of your 3 exams would technically be referred to as a midterm, even though it's no longer a midterm. There was a time in the past, and my own education sometimes involved a single test, middle of the semester, and a final. That was it. You screwed up one of them, you were in bad shape, because just messing up one test meant your chances of getting an A or B in the course was just not there. Having 3 exams gives you an opportunity to muff one a little bit, do another one well, and then the final being twice as much improved your chances. So the language we use, midterm, is a misnomer at this point when you have 3 exams. So each one of those consider a tri-midterm. One about every 5 weeks technically. Now the way I've set this up, because we're into the 7th week, I believe it is it not? This is the 7th, so we're at 8th week, and I should have technically probably done it at the 10th. The reason I'm doing it at the breaks I'm doing, so we don't have an exam and then a final immediately. That's tough. So we have like 4 weeks test, 4 weeks test, 4 weeks test. That's then the 12th week. 2 more weeks of new material, try to review in that last week, and then the final. So I'm trying to not, again, have your midterm followed with a final right on the heels of it. So since I see a blue book out, just a reminder, do get a few of them. green, blue, otherwise, but it is the small version, not the large one. Yes, a question, Marisol.
So we have to do some quiz on Friday.
Will be a quiz that I'll have tomorrow, but our midterm will be on Wednesday with the tutorial on Thursday with new material on Friday, and that's because of the Palomar broadcast schedule. They're going to miss an hour, and I wanted it to be a tutorial hour, not an hour of new material. Anything else before I'm down 15 seconds before I have to close? Okay, with that, did I get you got the roll sheet out, Dwayne. Thank you, appreciate that. Will, as we close out here, and